Now we'll look at something, so now we'll move on to something called improper integrals. And so we'll do two types, type 1 and type 2. And let's first consider type 1. And we'll have a look at something like y equals 1 over 1 minus x to the power of 3. And that will look something a bit like this. And I've drawn it badly, but here you can see this shoots up to infinity, and then down here it tends to 0. So what if we did the integral of 1 over 1 minus x cubed dx from negative infinity to well, actually, I think this will cross up here and it tends up to negative infinity at x equals 1, I think. Yes, at x equals 1. And so if we did that between negative infinity and 0, well, let's see how we would go. We would integrate this, because this is actually 1 minus x minus 3. We can do our reverse chain rule. We'd put up minus 2 up here, and then we would divide by minus 2 multiplied by minus 1, because minus 1 is the coefficient of x there, between minus infinity and 0. So then this becomes not minus half, just half, of 1 minus x squared. Now what we can do here is we then substitute in our 0, that's fine, but we can't substitute in infinity because technically speaking infinity doesn't exist. So we instead do as the limit as x approaches negative infinity of 1 to 1 minus x squared. And think about what happens. As we keep going left here, it essentially tends to 0. So that's exactly what's going to happen to here. It's going to become 0, because if we make this negative infinity, it becomes infinitely big because we're minusing minus infinity. So this becomes really big. And as we divide a number by bigger and bigger numbers, it gets smaller and smaller and smaller. So then this is just 1 over 2 minus 0, really. So that's just 1/2. So there's a finite value. That's type 1. Now we have a look at type 2. For example, let's take something, for example, 9 12 over x squared root x dx. And we're going to just turn this into x minus 3/2 dx, because 2 plus half is, not 3/2, 5/2 minus 5/2. And now we can try and integrate this. And then this becomes that. Now remember, we cannot divide by 0. So if we were to do this, that's fine, but then we'd end up with this, and then that in a way, is infinity. So there's no finite value. And that's because on a graph, this approaches infinity up here as it goes up. So at 0, there's no well-defined point. So therefore the integral does not have a finite value. Whereas in this one here, as we keep going this way, every single thing has a finite value. Up here is infinity, but everything along here has got a finite value. So that's type 1, with integral has a finite value because every point in the integral that we're considering has a well-defined value. But here in this one, type 2, there's no finite value because one of the points we've contained in our integral does not have a well-defined value. And that's basically it for improper integrals. It's not that hard. The main thing to remember is you can't divide by 0, and if you divide by, if that approaches infinity, as you keep getting bigger numbers, if you try to, in a way, divide by infinity, you'll get 0. So that takes that bit out of the equation, and generally that will mean the integral can exist.